Hello friends, welcome back. This is .NET Core 8 Web API crash course. This course covers every single thing that you need to know to build a .NET Core Web API from scratch. I'll be covering most of the important topics and in the industrial standard based code. So this video will be really interesting and useful. Without delay, come let's get started. So friends, before we dive in, this is the GitHub link where you will find every single project that I'm demonstrating. So feel free to go through and browse whichever project you like. For this specific video, I will post the exact link of the repository in the video description itself. If you would like to follow me on LinkedIn, Instagram, Twitter and GitHub, these are the links that you can click and follow me. I will be more than happy to collaborate with you, so don't forget to follow me. Now let's dive into the video. A lot of people have been asking me to publish a .NET Core full course, microservices full course, and I thought this will be the nice one to do it. And to keep it very simple and precise, I'm gonna take one simple example as an application, and then we are gonna build from there. And our application in this topic is expense tracker. All right. So expense tracker web API that we are going to build. Eventually we will build the UI in Angular 18. Web API microservices backend is what we are going to build in this video, and then eventually we'll be building Angular 17 and above as the UI front end. So in this video, what you can expect is we'll be going through the softwares to install some basics of web API. I'll touch base what is microservices web API, what are the important HTTP status codes, and then after that, right, every single thing is completely hands-on demo. No chit chat in between. Everything is going to be very useful. Every single minute that you spend is going to be very useful. And at this end of the course, what you will learn is what I have showed in the slide. Basically, we'll be covering .NET Core 8. We'll be using C# as our primary language, and I assume you know some fundamentals of .NET Core, how to build .NET Core, but web API, microservices, concepts and all I will cover, do not worry. We will also use Entity Framework Core 8. We will use EF tools, EF CLI commands, for the database migration and all of those database related work. We'll be using our SQL database. So which means in this video, I will also cover how you design this expense tracker application from the scratch. In terms of database design, I'll cover all of the important topics from the scratch. And our coding is completely going to be asynchronous programming, which means we will use almost 100% async await keywords in our complete programming from start till the end of the layer, right? And I'll be using our entire layer architecture with the repository patterns, and then for logging, that's the important thing. There's one superb framework from Serilog, that's a logging framework. We'll be using that. And not only that, we'll be using Azure Application Insights to see how we can push all of our telemetric logging information to the Azure, and see from how you can do that from the Azure as well. And then we will also use the exception handling at a global level. And then finally, right, eventually and finally, we will be using authentication and authorization for this application. And our all-time favorite AZ, Azure AD B2C is what I will be using it for this as well. So from a zero to hero perspective, right, if you don't know any of these things, don't worry, I will cover every single thing. All what I want you to do is learn patiently, do it with your hands-on. Practice is very important. And then you can become a full backend developer by the end of this course. Eventually, when we finish our Azure other concepts and UI, you can claim yourself as a full stack developer. So I will cover those as well. So this video is going to be really useful, and no more delay. Let's get into each of the topics. Okay, all hands on deck. First thing is we have to install the software. Feel free to skip the software installations if you have already done so. Basically, for newcomers and beginners, I'm been using Visual Studio 2022. That's my favorite IDE. So its community version is free. Go to this link and you see in the picture there is something called free download here, right? Click on it and get it downloaded. All right. After that, there are a couple more things that you need to install to go through this course. First thing is SQL Server Management Studio. If you have a database connected to Azure or anywhere, then you don't need it. But I suggest, as a developer, install the softwares, the SQL Server Management Studio, which will install the database engine on your machine. If you do that, you can create a database and do every single thing related to the database. So I really suggest you to go install the latest version. As of this recording is 20.1. Install SSMS in your local machine, followed by go to this link. Here we did talk about, go to this link. The next one is the entity framework code tool reference. So go to this link. This link is going to talk about how to install the EF code tools on your machine globally. Don't worry if you get confused by reading this document. Just feel free to continue with me. At the time of database design, I will tell you how to install, what exact command that you need to use to install it. So don't worry about it. All right, so the first two things is important: database design, the database, and the Visual Studio 2022. Fine, so software is done. The next thing is, let's get started with what is web API, microservices, difference between these two, and what are the important HTTP status code. When I go through this video, please, I will also cover important interview topics. I myself an interviewer, so I know how to ask, I know how to evaluate the candidates. So at the at that point of time, right, based on how candidates are responding, we can easily judge, okay, fine, he or she is sufficient enough, they can pick it up, they're good, they know some knowledge. So be patient, I will explain you important thing as we go. And so what is web API? Web API is a set of protocols and tools for building software applications. It allows different software systems to communicate with each other over the web. Web API exposes endpoint that can be accessed via HTTP methods. There are these 4 important HTTP methods. So let me explain. So this is just a definition, right? So web API is basically, you split this web API. Web API. API stands for Application Programming Interface. And we're dealing this with the web application, so that's why it's called web API. So in short, for you guys to understand what is web API is, basically web API is nothing but a functionality that is written in the server side. Like you ask for it, it does something and give you some response. So you send a request, it is going to give you a response. The response is always going to be, most of the time it's going to be in the JSON format. And very important thing, web API deals only with the data. It doesn't return any HTML or anything. They deal with the data. It's a lightweight thing. All right, so that's the at a high level of what is APIs stands for. So when we talk about it's a tool building for software application. Basically, you will have some application like your mobile. Everybody these days have mobile applications. You have mobiles that has a lot of applications, right? It talks to the backend without you knowing it. It exchanges the data, and then the data is what you see on your app. So for example, the primary purpose of the web API is to enable the interaction between the disparate systems. For example, a client application, right? You could be our UI application, which is in React, Angular, or any mobile application or anything. Client application means a application which is facing the customer. Okay, they can interact with the server to perform certain read and write operations. It's called CURD operation, and that is what this web API is. All right, so what are the components? Components, there are a couple of things. Endpoints means basically a direct URL that is unique across the web, and that URL, right, it's where your resource is present. So for example, if you want to get some product, it's going to be some domain name, let for example learn smartcoding.com/API/products. If you access this URL, you're going to get some data. Okay, whether the data is protected or not, don't get into it now. Basically an API which will have a unique URL. If you access it, you're gonna exchange the data. And there are a couple of methods that can be used in terms of web API. They're called HTTP methods. Okay, and like get, post, put, delete, those things. Now important thing you should also understand is web API deals with a protocol called HTTP and HTTPS. The preferred way of doing is HTTPS, Hypertext Transfer Protocol Secured. SSL layer will be included, which means the data when transfers from your place to the server to this place, like the back to the client, the data is actually encrypted. Nobody can tamper the data in the middle of the network. That's what is important. So web APIs are always dealing with this HTTP protocol, HTTPS protocol. They're secured and they can be accessed via internet globally across the world. Anywhere you are in the world, you can still access that over the HTTPS in the browser or wherever the mechanism is. The next thing is request and response. We already spoke about it. You send a request, you're gonna get the response, and the response, generally speaking, it will be in the JSON format. If at all clients wants an XML format, it can send an extra header to the request. Hey, give me in the XML format. Our web APIs are clever enough to convert it into XML format, right? So that's also possible. So that is what called web API. Okay, so in a typical web application, right, like we already saw in my channel, a big one called e-commerce application. There'll be several endpoints to deal with products, orders, users, cart, this, that, so many things. They're all just an example. Everything is, each one of those things are called functionalities. Now let's talk about microservices. Okay, so people get confused with microservices and web API. I know for sure a lot of people get confused, right? They think both are same. Microservice is nothing but their architectural design patterns, right? They are called architecture. So basically, a microservice is a small independent service that does one thing well. It's a part of a large architecture where multiple microservices work together to form a complete system. Let me give an example. Consider the e-commerce application. If a company A builds an e-commerce application, let's say for themselves, right? They build a small e-commerce application for themselves where there's only one project. They build every single thing in one project. Now the project is very big, being big, like it could have reporting, address, orders, products, cart, wish list, this, that, so many things in one single place. If that business gets grown, that application will be deployed several instances in the computer, which means you're just duplicating every single pieces of code into multiple places. Consider this, right? If when you go to Amazon.com or Flipkart or whatever, wherever you belong to, right? If you go to Amazon is the best example. You go to Amazon.com, what do you do? What do we do? We go browse the product, we go inside the product and see the product. How frequently you're gonna order the items, how frequently you're going to go to the address and change your address. The frequency of these things compared to product search or product related stuff are less, right? Which means only the product thing, it's needed more attention, more load. So microservice, what it will do is, what we will do in terms of microservices, we split this big application into chunk of small independent application. If you remember, in our e-commerce application, we have 4 different microservices, right? Product, orders, wish and cart separately, users separately, user profile separately. Why? Product is a microservice that does all product related work. Similarly, orders, address and other. So when we bring this to the production, based on the workload, we can scale up that individual component to more instance. For example, if a lot of people are using product APIs, product API is what needs to be scaled up. When we say scale up, instead of one instance, multiple instances they will deploy, so load can be evenly spread and it can be handled. Whereas address change and all is comparatively less. People will be calling those kind of APIs very less. Not everybody is going to change address every single time. So that's the concept, right? We split the big application into small chunks that becomes an independent services. Okay, so that's called microservice. So if somebody asks you, do you know microservice? Yes, you should be knowing. After this video, you should know what is microservice. All right, and somebody knows, ask you about web API, you should know what is web API, that which we are going to build now. So whatever I explained is what is in the scope, basically breaking down the application into smaller loosely coupled services, and each services will become a its own microservices, like microservice. If you split, micro means small, services means basically it's going to serve something. So that's what it is. Okay, so that's the scope of the microservice. Example, I already discussed all of these things. This is what the examples that we just discussed. E-commerce is the best example that we can talk. And let's summarize. So a web API is a mean of communication over the web, while a microservice is an architectural style that involves building small independent services that often communicate via APIs. This is important, guys. If you say you're a backend developer and you know web API, you should definitely know what really a web API is, what is microservices are. Okay, they will definitely ask you. Maybe we will talk more about a separate video in this interview related stuff. Please let me know in the comment section if you're really interested in the interview stuff. I can help you guys. Now, HTTP status code. So I'm going to be really quick about this HTTP status codes. It's always good to understand some at a high level of what of these things, so that when we get into the real hands-on coding, it will be easy for you guys to understand it. Okay, so HTTP status code, HTTP already we know that's a protocol, and it is giving us a standard status code which is already defined. So what it says, HTTP status codes are standardized codes which has already been predefined, written by the web server to indicate the result of a client request. They are grouped into 5 categories. Okay, so you send a request, the client is sending a request to the server is responding to the client. When it responds, it will always have one meaningful HTTP status code. What kind of status codes it is returning is what we are going to learn now. 5 categories. This starts with 1x, 2x, 3, 4, 5. When I say xx, it's going to be like 100 and above within 200, 200 and above, 300 and above, 400 and above, 500 and above. What you need to know is, you should first know just at a high level what are these things. That's it. You don't need to memorize every single status code. One related status codes are all information, which means you have nothing to do with it. It's just FYI, right? For your information, something like that. 200 latest status codes are called successful status code. The server is responding to the client that you gave me a request, I processed it successfully. What kind of success varies based on the different status code. We'll talk through it, don't worry. 3 is all redirection, which means there is some action required from the client side. Today there will be some URL. Okay, down the line after 5 years, for some valid reason, the URL got changed. The server can now respond, hey, this was the URL that you hit, but we changed this URL to this. Please go to this URL. Okay, that's the typical scenario. 400 is all important thing. Say 400 and above, right? They're called client errors, which means client sent a request to the server. Server is saying, hey, I received your request, but there's something wrong in your request, which means any 400 related error can be corrected by the client and can be resubmitted to make this successful. That alone you remember. Okay, 500 means client have nothing to do about it. There is something seriously wrong at the server side, and we are just saying that something went wrong in the server side. Could be anything, depending on the status code. We can tell you what it is, but client cannot do anything. Okay, that's called 500. So let's quickly go through these things. I'm going to walk you through only important things. So 100 is just informational. So let's talk about this 200, right? When you save some content, when I say newly save a content in the using web API, you should always use 201, which is called created. Okay, when you are processing a get request, which means you're sending back the data, you use 200 okay request. 202, 204 are important as well. Not everybody uses properly. 202 means I received the request, I verified it, it's ready for processing, which means you're just responding to the client saying accepted, your request is accepted. That's it. Whether the request was successfully processed or not, God knows. That's a different story, but we are just telling there are different scenarios why you need to send those things. Okay, similarly 204, which means for delete and all, right? When you process the request, everything is done successful, and we are just saying there is nothing else for me to return it. Let's say you're trying to delete a record. You deleted it. Now what else you will return in that scenario? You deleted the record itself. You cannot return anything. Okay, that's where you use 204 no content. Okay. The next one, the 300 related things, they're all like I explained you, they're all redirection related stuff. And then 400 is what we will go through. It 400 means bad request. If you're submitting a form where age, name, address is all there, and then you forgot to mention the zip code and the address. Now the server is saying, hey, I received all of your requests, zip code is missing, which means incorrect or incomplete request, data in the body is incorrect. Then it will send back saying 400, hey, please fill up the zip code. That's also important. That's also mandatory. That's where the client will recognize, okay, intelligently recognize, okay, this is what the request is, we need to fill up. They can resubmit successful. Similarly, 404 means you're trying to find a a resource which is not present, you send 404 not found. Okay, important status code, all of these things you remember, they are definitely going to be asked in the interviews, especially 400, 401, 403, 404. They are like super important. You should know what are those things. So we know 400, we know 404. Talk about 401 and 403. If server and clients, if server is like protected, if server detects that anonymous requests are coming, it will reject with 401 not authorized. It doesn't have header, it doesn't know who you are, so it doesn't really care about processing, so it will reject with 401. However, if you send with the proper credentials, everything is looking good, if server recognize who you are, but you're trying to do some action which you're not permitted to do, that's where it sends forbidden. Forbidden means server understands who you are, but it refuses to do so because you're trying to delete some record or update some record which you're not authorized to do according to your role. That's where you see 403. So they're all important, right? The next thing is 500. Everybody knows in this world 500 is basically okay. So before we go to 500, let's one more thing. 409, not frequently used, but good to know. 409 is basically when a particular record is being trying to update with multiple people in support team or whatever it is, right? Real timely, same record is getting updated at the same time. If the server is detecting such kind of thing, optimistic and pessimistic, update. They call there's a separate concept. If the server detects, it can return 409 saying, hey, conflict. Somebody else is also trying to update it, right? Those kind of thing. Last but not least, 500 series. 500 is something that we didn't handle the exceptions properly. Something really screwed up. Exception occurred. That's where you send 500. Okay. 502, 503, 504 also common. If the servers are not accessible for a different reason, you send this 502, 503, 504 automatically. Okay. You don't need to do when you deploy a particular URL and you get into any of these 502, 503, 504 scenarios, automatically you'll get it from the web server itself. That's beauty. Okay, we don't hard code and send anything like 502. If you hard code, it's wrong. If somebody is going to trickily ask you, can you send 502 by yourself? It's a stupid question. Basically, you're not supposed to send 502. 502 means the request did not even reach your application. That's where the 500, 2, 3, 4 comes into picture. Okay, so definitely do not answer yes. It's really a tricky, confusing question for you guys to evaluate, right? I never ask this kind of stupid questions anyway. Alright, so I think we are good with the definition and some basic understandings. It's completely put your hands on desk. Let's get into the coding starting now. In this video, I'm going to teach you how to design a simple database from the scratch. So you don't need to know any of the basics. I'm going to touch base all of the important basics that you need to get started with this database design. And in this video, we will be talking about a simple application called Expense Tracker. So it'll be useful and interesting. Now let's dive into the video. So anyone who is not aware of SQL or you do not have any setups in your local machine, I will just quickly tell you what you need to do. If you are having Windows machine, go to Google and search for SQL Server download. Okay, there are two parts. SQL Server is something, a database engine, which is has to be installed on your machine to get your server up and running. After that, there is something called SSMS, SQL Server Management Studio. That's the IDE concept which you will do all of the designs. Now, when you go to this SQL Server download, there are full version for developer that's also free, and also the Express version is free. So I've downloaded the Express version. Once you download the Express version and get started with the installation step, it'll be pretty easy. Quickly do it, and it will ask you to download SSMS. Either go from that wizard, or you can search for SSMS download for Windows and you land here. If you download this and install, you're done with the software. So once you're done with all the installations, now open up SSMS. It will be like this, and then click on Connect Database Engine. Because it's localhost SQL Server Express, this is what the server name will look like. And choose the Windows authentication. Click on the Trust Server Certification. See, I have the latest version of 20.1 SSMS, and then if I connect, it will connect to the local installed database. By default, you will not have any database. I created a database with all of the tables. That's why for me it's showing up here like this. Okay, so don't worry if it is not showing up for you. As you proceed, you will get to know how to do it. Now, before we get started with database design, who are not aware of this SQL Server, SQL is basically structured query language. That's one of the database where the data are stored in a relational concept. It's called RDBMS, Relational Database Management System, and one of the RDBMS is the SQL, which is from the Microsoft. There are other RDBMS also, like Oracle and other things, but we are going to talk about SQL. So we know what is SQL. It's basically we are persisting our data in the tables format, and we are going to use the SQL Server, which is from Microsoft. Okay, this is structured query language. Now coming back to the database design, my application here in this example is expense tracker. So let's talk about little bit about expense tracker. The moment you hear about expense tracker, which means an application which is tracking the expense of a user. So the expense means like on your day-to-day basis, if I wanted to track my expense, I don't want it to write it in an Excel or something. I can have this kind of application where I put all of the information into as a record, and then later I can go back and check what and all I have done, right? Now, when you design a database, what you have to think is based on the application core concepts. Expense tracker means that is something that we're tracking an expense. Expense is nothing but you're spending something, you're getting some products, right? So how you have to think about this database designers, think in a broader way. So now expense tracker is the application that we know, which means like consider yourself, you are going to a shop. It could be a healthcare, medical shop, it could be a grocery shop, dress shop, anything that you do, anything you buy, that's an expense, right? So when you talk about expense, so let's quickly do something. So I'm going to take my whiteboard. Let's see. So first one that we have is expense. So our application is expense tracker. So we'll put it here. All right. So the next thing that you have to think of is we are doing some expense. So definitely there is expense related records. So there is definitely something related to expense records. So let's keep this here, and then expense will have something related to its category. Like it could be garments, it could be grocery items. So there's something called category. All right, what else we have? And you do some expense using like you pay the expense using the credit card, debit card, and or maybe a cash. So definitely there is something called expense type, what kind of type that you do. And because we are dealing with each user, definitely there is something related to user. So we will name it as user profile, where we will save all the user information. Now We have category, we have expense, we have expense type, and then if at all you wanted to store what kind of card you used, I'm going to have something called credit card, right? It could be some card details, debit card, credit card, whatever it is. Now, one more thing I wanted to do. Now, a family, will be more than one person. So, let's say husband and wife is doing their expense individually, but then they wanted to club together as a family for a given month. So, there is something that we can track as family records. So we will track this as family records. So we know now at a high level what kind of tables we want. Each table will hold their respective information. So this is how you should picture yourself based on the application. Now I'm considering very simple, like to get started with the application. The same application at the end of the video or in a separate video, I will tell you how requirements comes in and how you expand the existing application, how you expand the existing design to support the new features. That is what generally in a real-time organization you will have to go through it. So we will mimic such a similar concept. Okay, so we'll deal with only these things. Now let me open up the SSMS. What I'm going to do is I'm quickly going to bring up all the tables that I've already designed. Okay, so the moment it comes like this, it will automatically, I mean, since all the relationship has been already declared, that's why it's coming like this. Okay, so I'm gonna put it separately. I'm gonna really delete everything. Okay, so let's picture only with what the tables has. So exactly whatever I just explained, right? So expense type will have a column with a unique ID. That's called expense type ID. The table name followed by ID is what generally they will put, or you can usually put just ID. It's almost same. Okay, and expense type will have some name. That's why it's expense type name. Now expense category, each expense will come under some category, right? So it could be it could be a garments, it could be grocery, medical, healthcare, it could be for anything, like even for movie, right, for entertainment. So that's why I have something called expense category ID. Again, table name followed by ID, and then it has a name, so I'm storing the name. Okay, now like I said, we are dealing with each user, so I have something called user profile, user ID. Again, same. I wanted to store display name, first name, last name, email ID, and then we are going to deal with Azure AD B2C. So I just have an extra column called AD object ID just to reference which user belongs to what. Okay, just for cross referencing. And then I have something called family ID. Basically, one user or more than, like husband wife, right? Husband wife, or even grown up kid who's going to college could also be part of the family. So let's say three people are registered as a users, but then they belong to one family. Now how do you know? So I create a family table where I record a family name. The family ID is what I'm going to give it for all the three people, which means for a given family ID, all these three people belong to one family. That's why this family ID is here. Okay, again, the next one is the credit card. I wanted to just store the last four digits of the credit card. And like if a family has using 5 credit cards, I wanted to store 5 different credit cards information here just to track which credit card has been used, so that I can pay my bill properly. And because this is a common table and we will have a lot of users, I wanted to know which card belongs to which user. I don't want to expose anybody else's cards to a different user. That's why this information is associated with the user ID column. Okay, so you got the user ID column. Now coming back to the last table, expense table, again expense amount will be there. Because an expense is associated with a category, the category ID will come here. It is again expenses associated with the expense type ID came here. For that expense you would have paid using a cash or a card, so card ID will come here. That's how these three came. Other than that, just a description and when the expense as incurred. Now coming back to the SQL, right? Important few concepts. Primary key in SQL is basically a unique key in a table which will not have null value. Okay, unique key is another concept where every single data is unique, but it can have null value also. This is one of the interview questions, so be careful. Primary key will never ever have null value. It cannot have. Okay, it has to have a value, but it has to be unique. Now, in all of our table, there will be one primary key at least. Okay, the single primary key that we have it on all these table are these IDs: expense ID, expense type ID, all these things, black color you see, they're all primary keys. Now, there is another concept called foreign key. Foreign key means a primary key in a table can become a foreign key in another table. The other table is called child table. Okay, now let's consider this example. Here, expense type is a primary table. This is also a separate table. Credit card is also a separate table. But these are belong to this tables here. So these becomes a foreign key. So this all primary key. These three are foreign key because this is a child table of these three. Just because it has its primary key associated here and it is called foreign key. Similarly, you see this is primary key, you have it here, it's a foreign key, so this is foreign key. Okay, so we know now what is basic information of primary key, foreign key, and what else. I think, yeah, this is what it is. Okay, now let's go back to SQL and see how we will do it. See, for the first time, if you're creating database, you can use create database name, but let's be practical. When you start developing in your own system, this is the only place you will use it. But in an existing organization, all of the database will be already there. It is very, very unlikely that you will end up creating your own database unless it is a really new project with everything from scratch. Okay, I haven't seen it in my last 15 years anyway. So now, how do you create a table? So in order to create a table, you use create table name, and then you define the columns. When you define the columns, there are a few important things that you need to understand as a basic user. You always have a column associated with a data type followed by some constraints. So in this case, the family ID is of integer type, so I define integer. Family name is going to store the text, so I define as nvarchar and maximum of 100 characters. Okay, now so far we are good. Now let's understand the constraint. I want this ID to be auto incremented. Anything that you wanted to auto increment will have an identity column. That's why we use identity and we say 1 comma 1, which means it starts with 1 and it will have a interval of 1. So if I say 1 comma 10, then it starts, let's say 10 comma 10, it starts with 10, the ID, and then it follows by 10, 20, 30. It will increment by 10. That's what the difference. Okay, but generally depending on the project, but for us it's 1 to 1 is fine. And then there's another constraint called not null, which means you're saying you're forcing the stable record on this column. You cannot have a null column. Like when you create a entry here, you should definitely have a family name given. That's all. Now you can here itself say primary key. This one, if you can just copy in here and put here. That will also become a primary key. But what's the difference between having a primary key written here and separately here? The difference is when you add a constraint separately, you can name the constraint. So we're saying add a constraint to this table and the name of the constraint is pk. It's a standard primary key underscore family ID. Basically the table name followed by the column name, and then you define a primary key. You specify what is the primary key. This is the right way of doing, so please follow the right way of doing the SQL scripts. Okay, do not just do something for sake of doing. It is not going to help. By this end of this video, definitely you will have some solid basic understanding of database design and some table designs. Now let's talk about another table, right? Same thing, table, create table name, all of these column names. We already spoke about second parameter, like the space followed by is the data type. So in this case, it's an integer. All of these things we can understand, and we are also defining the constraints as not null. Okay, and what else? Again, we have two more constraints. Okay, before we come here, there's another constraint here. See, this is also a named constraint. Okay, we are saying if the display name is not given, make it as guest. So constraint name, the default is the constraint, the default is guest if you don't receive a data. Great. Now this we know we are defining a primary key. Now in order to define a foreign key, okay, we are saying a constraint name, here in this case foreign key, so that's why fk followed by this table name underscore under the next table name. The next table name is from where this is referencing. In our case, it's a family table. That's why user profile is this table, family is the another table from where it is referencing. And then you define that saying foreign key, which is the foreign key here. Here is the foreign key. This one is here, okay? And then we are saying this is referencing the table called family table. In the family table, this is the ID it is referencing. That is what this statement means. Okay, so now we know default constraint, primary constraint, second like the foreign key constraint. Now if you see rest of the thing, everything is same. So either you can create the constraints in the table, or if the table is already created, you can use alter table name and add the constraints. That is also possible. So I'm giving you some different flavors. Okay, either first time creating the table, this is possible, but let's say down the line the table is getting expanded, at that time you want a foreign key, of course you can do by using this kind of a separate script. Okay, that's called alter table script. Great. Now we also added some index. Ideally index is good to have it on a table, so it will index the data. The way you query it will be faster, but for the simple application we don't really need it. For the standard way of explaining the indexes, I have also added two more indexes here. That's what it is. And then reminding and all, it's a normal thing. We're just putting some existing data for the family table and for some expense category table, type table. Okay, so like card, cash, check. So this is what we have done. Now so let's summarize, right? So what we have done, we know how to install on the setups files like the SQL Server Management Studio, and then we learned about how you can start with the database design. Think of application and the application, what it is doing. Based on that, you visualize what kind of data you need to save it. The data that you're trying to save is what will become a table, and you can add the appropriate column names to save the data. Okay, and then we also saw how you can use the designer view to design the tables, and then this is how you use the SQL script to write the to define the tables. Okay, and once you define everything properly, if you go again to design query view, if you select everything based on the design, you can definitely see everything is added properly. Okay, its relationship is added properly automatically. Okay, so that's how it is. I hope you enjoy this video. This is the simplest thing that I can explain for a database design from scratch. I hope you enjoyed this video. Alright, now we have installed all the softwares and know the basic concepts. Let's get into it. So I have opened up Visual Studio 2022. Click on new project. Here you type web API. It will filter down the project templates. Choose Linux, C#, and then the first one is the ASP.NET Core Web API. So choose this and click on next. Here your project name. I'm going to put this application into one of the folder for me, which is under the Learn Smart Coding folder that I have, and I'm going to name this as Expense Tracker. So our application is Expense Tracker, if I have not mentioned it. So Expense Tracker is the application. The first project that we want is web project, so .web. Okay, the project itself that we choose is web project. So you click on it and everything looks okay. So I wanted to put this into the expense tracker folder, so that's why I just put that one. Click on next, and now it will ask you to choose the framework. I have choose .NET 8 framework, and leave all of these things to as a check mark. But it's a good idea to create controller, not the minimal API. Don't get confused with minimal APIs. We're not developing any minimal APIs. Okay, so it has to be this way. And probably in the software section, I forgot to ask you to install .NET 8 also, so that also has to be installed. Now this is the application, right? So this is the project, and it has some settings, all of these things. Now what I'm going to do is I'm going to go to this project folder, and this is where the place. Let me see, everything looks good. Okay, so there is multiple folder, by mistake it was created, so I'm gonna cut this and put it outside. I'm gonna close this for a second, cut this completely, and I just want this to be inside this folder, not so many folders. Okay, so now I've reset this properly. Now I can open up the solution. Solution is open. Now here is what we have to do. Okay, we will run this, and this, if this looks good, if it works the way the default template has been given, that's fair enough. Let's start with the next work. Okay, so it's running great. So Swagger UI is coming automatically. They're all in place by default. All right, now what we will do, right click on solution, create a new project. In this time you choose the library project. Okay, so we're going to create 3 projects called core, data, and the service. Okay, that's going to be our entire architecture. Okay, so we will be creating the other 3. We already have expense tracker.web. This time it's going to be expense tracker.core. That is just a library project. I choose this. I choose .NET 8 as the long-term support as of we speak now. That's the latest version. Click on next. The project created. Similarly, I'm going to quickly create other 2 projects. So you see this, now the folders are in the right folders. We just need 4 different folders for 4 different projects. Now it's same class library, expense tracker.service. One last project, this is going to be expense tracker.data, where our database and all the database latest stuff is going to be here. Okay, so we will create the last project. Click on next, choose the same .NET 8 long-term support version, create. Great, all of these 4s are in place now. This is an entire architecture layer, so basically each project depends on the other project. So here what we are going to do is click on the dependencies, and then you select all the projects. See, web project is at a high level, it will depend on all the projects. Okay, for the service project, it will talk to only the data and the core. That's why we have assigned for data just need only the core. Okay, core is the project where we will put all of the entities and models. It's a common project, I would say. Okay, core doesn't need anything. Core is independent. Only others require core to be their dependency. So what we have done, we created a project in Visual Studio template. We created 3 more projects to form the entire layer of the application. So those 2 works is what we just did it. The next thing is to add the NuGet packages in the right project to get our database that we saw, right? The database design. We need to bring that database design back to the convert into the models into this project. Okay, so for that we are going to install certain NuGet packages. So you can right click on the project, go to the NuGet package, and you can go to the browse and say microsoft.entityframework.core. It will now show you the list of things. Select the one and then install it. It will ask you accept everything, you do it, it gets installed. This is one way of installing. Let's say you already know how to what kind of packages you need, what version is that. Let's say you have those information. The other way of doing is go to the project, right click, just like double click on the project, and I already copied these thing from the developed application. So I need entityframework.core.design.sql.abstraction. These 4 different packages I need. I can also go and install one by one NuGet packages just to show you different flavors. You can do that way also. So I'm going to install these 2 different these 2 sets of NuGet packages in both core and the data. Okay, you'll come to know why we have to install these packages in both this project, but basically you're going to do these 2 things. Okay, so here also let me copy it from the other .core project, and I have paste here. Okay, so if you do Control Shift B, which will build the project, when it builds a project, it will actually install everything. Now we need this entity framework related packages in the web project also, because these are the project which will typically use this entity framework code packages for its core building purpose. So now packages are installed, Control Shift B or go to the build and do a build, project will get built. We have not done anything, we're just making sure the packages are building. Okay, now I copy pasted this whole the text file. Basically, if you see in software installation, we did install the .NET tool. If you have not gone through that, basically if you execute .NET tool list dash dash global, and this command, like, which is there in this file, right, take it from this file and you execute this. I'm going to do it in my PowerShell prompt. If I do, it will tell you what packages is installed on my machine. So I do have .NET EF tool, which is 8.0 version. If you do not have it, I have also given links here, like the command here to install it. So if you have older version, there's a command to update it. If you have not installed at all, just use .NET tool install dash dash global .NET EF. It will install the latest one. Okay, whatever the latest is, you do need to get the 8 itself. If you see this video a little bit late, probably you're gonna get the latest version at that point of time. Now, to scaffold the database, right, this is the command. So let's say you have installed the EF tool. If you say .NET EF, it will list down three commands: uses database, DB context, and migration. What we are going to do is under the DB context. So let's say .NET EF space DB context. It will list down all the other commands within that. Info, list, optimize, scaffold, script. Script is to generate the script based on the migration script that we have. Scaffold means we will directly use the database connections thing to connect to database and read the objects and convert into the models. In order for us to do that, this is till here, whatever I've highlighted is the connection string of my local database. Okay, you have to just change your server name. In this case, my name is Karthik is a server name. At the end, you can see dash o entities is the folder name, dash d is the, it is going to split and do it. So I want this entity to be under the core. I go to this particular location, go here and say cmd. Basically, this is the shortcut to open up that location in the command prompt, how I exactly did. You can also say cd space this location, you can come. Now I copied this entity like .NET EF DB context scaffold followed by the connection string name and then bunch of other properties. I'm gonna do hit this together. It's building. Okay, it's building the project and it is going to generate the class files for us, which it did. Great. So we have 6 tables, 6 classes plus another class, extra class called expense tracker context.cs came. Let's understand this. So this is a context class. It's basically a class that inherits from DB context. DB context comes from Microsoft.entity framework code. Okay, so we inherit that and then it will automatically ask us to do this. So all of these codes are generated, but it's good to understand. This is the constructor class where we pass the DB option, and DB set is the one which will be pointing to the tables. So we have 6 tables, so that's why it's public virtual DB set of each class. Each class is each table. Okay, now whatever I deleted is not required. It's basically hard coded based on our command. We will pass that from programmatically. Okay, now all of these things that you see, right, that is based on the database design that we saw in the video. You have already designed everything based on the object it read and then it populated these things. Now each of these class will have its relationships automatically, its properties, like how they are related, the primary key, the second, the foreign key, all of these things. Users expense table will have these things, right, as a foreign key. That's why you can see all the virtual classes. Now it has made our life easy by using the scaffold thing. I'm just going to rename this as expense tracker DB context instead of just context. Now let's build this and make sure whatever we have it on our project is building. Is it building? Great. Now let's go to the next step. The next step of our work is to connect certain dots. Okay, now let's connect the configure the db context in the application in the program.cs file. Okay, we have the db context ready, we haven't configured it yet. Here we need to do that. That's our next work. Now there are two parts in this program.cs. Okay, if you are familiar with .NET Core, first is configure servers. There used to be a separate method, and pipelines for the middleware. There are two methods. See, when .NET Core initially came, there are two things. It came in the startup and the program.cs. One is configure service method and configure method. In interview also ask what is the difference between configure service and config. Basically, configure services is where you configure all the services. Configure method is where you configure everything related to the pipeline, the middleware. Here also same concept, but they are all together inside the main method itself. Okay. Now, if you see whatever I'm typing, the first part which will come as builder.service, they're all servers, which means configure service later stuff. All the other stuff which is based on the app, like builder.build, and then it's coming as app, right? App dot everything is middleware. Okay, this part is the servers, the second part is the middleware. Alright, so now let's configure the database thing. So builder.service.add db context, and then you pass the db context name, and then you're passing some options. Okay, so they're coming from entity framework and SQL server. So the option that we pass is option.use SQL server, and you need to pass the connection string. We will read the connection string from the app settings, and let's define this configuration is equal to builder.configuration. It's just, or you can use builder.configuration directly also. Okay, so we will read this configuration, and then we are also providing little more options. So this is for retrying mechanism, right? If it tries to connect to database during the starting of the application, if for some instance there is a network glitch, it will retry a couple of times until it succeeds. Okay, that's the option that we write it in line number 30. And remember, I have also given the comments where 33 line number is required only for your initial development purpose. Basically, you should never ever enable this. This will log every single sensitive information that the query is executing, including the parameter name. That's why you should never do that. Now once that configuration is done, that's it. The database configuration is done. We need to add the the database db connection string alone. We will do it in a moment. But next is our data layer to configure. Okay, so basically when you develop an application or a functionality, you already know what you want it in the controller. From controller based, what data you might require to get it from the database. So I suggest for anything like this, always go from the back. You build something in the database layer, expose that to servers, do whatever you wanted in servers, expose that to a controller. Controller is what you build finally, and then use that. Okay, so remember, we need to do all of these things. So let's take a look at our database. So we have 6 entities. To simplify this web application, what I've done is I have grouped these entity into 2 different groups. For example, family table and user profile table are one group, so I am going to have that as one repository layer, the other 4 tables into another repository. But typically in a real world, in an organization, each entity itself will be huge, so every single repository will be for every single entity. Okay, it is very unlikely that you will have repository layers with combined combination. Okay, but this is just for our understanding purpose. It's simplified. I've also explained why we are doing that. It's to simplify the process. Instead of 6 repository layers, 6 repository classes, I just want 2 class. I grouped those things into 2 things. Okay, so remember that it's that's something that you need to remember. Alright, I'm going to show you whatever I've already built. So if you see under the users, right, we are going to create this code operation. Okay, so under the expense, we will have some utility thing related to the types category. and other things related to the expense. So we will be using these. We are eventually going to build these endpoints. Okay, types, category, credit card, they're all like kind of utility where it just gets the data. It doesn't have any code operation just to populate it. Okay, so even if I run it, it's already giving me data. Okay, so this is what we are going to do, which means there will be two controllers, services, repositories related to these things. So you pass the user ID, you pass the family ID. Based on that, it will get, or even if you want to get one single expense ID, it is possible to get one single expense ID. Okay, so these are the concepts. Okay, so what I'm going to do is, let's start with the data process. I'm going to create an interface is called basically I name it as I user repository. It's called repository thing. And then remember, this interface needs to be public. Right now by default the classes are created as internal, but it has to be public. After that, let's say I have a method called get user ID async. We already spoke about async await recently. Take a look at this video if you have not. So this is an asynchronous method. It gets user ID as input. It's returning a user profile. Because it's asynchronous method, it's going to return a task of user profile. Okay, nothing else. It's basically returning a user profile. Remember that. Okay, that's the definition I have. Now for that, I need to do some implementation. So what generally you do is, the naming should be like almost same. So I use a repository, so implementation class name will be just user repository. So again, by default it's internal. Let's change it to public. Okay, and then you inherit the interface. The moment you inherit the interface, it's going to give you this work. Control period will give you options. I will choose implemented. That's why this method automatically got generated. Okay, so at this layer, right, at this layer, all what you need is you need to access the context, the DB context. So CTOR and put a tab, it will generate a constructor automatically like this. Here I'm going to inject the expense tracker DB context. The moment you say control period on top of this context, it will give you these options. You can have the primary constructors created. That's there from .NET 8, and then you can also create a regular field based injection. Now very easy. Now the DB context will have all the DB set, the tables. In order for you to access table, anything that is DB set, it's called tables. So now by default you have a lot of synchronous asynchronous methods. So let's take a look. So context dot table name, here we are dealing with the user profile. So user profiles dot, see, find is the synchronous method, find async is the asynchronous method. I will use asynchronous method, and then here you pass the incoming user ID, because user ID is the primary key here. So the entity framework knows how to query the table based on this primary key. Okay, that's the find async methods concept. Now I will store this into user profile, and if you hover it, you see it's returning a value task of user profile. Okay, it's not returning just user profile. Now what we will do is, we will use our asynchronous concept, async await concept, to make this as a retrievable data. Okay, so now if you just try to return the user profile, it will give you error because it is value task of user profile. It's not just a task of user profile. Okay, so either you can use async await here, or you can use as task. We will use async here and await here in the line number 20. So we are awaiting for the result. Now the result came. Now you can also directly return like this. Okay, it's a simplified code. Okay, so don't worry about this green color. Basically, if you pass an user ID which is not valid, it might return null. That's what it is complaining. But let's try to understand. Okay, now next is we have the repository layer. Let's go into the next layer called service layer. Okay, under the service, I will create a meaningful class called iUserService. iUserService, again an interface. It should be a public, it should not be an internal. I will change this name, access modifier as public. Here get user by ID. Again, this is a method. This is going to pass the user ID from the controller. Okay, basically this is only invoking, so it will also pass user ID. But here let's for a second, let's assume void. See, user profile is an entity which is directly having details of the table. We should never expose the entities directly to the users, to the consumers, because it might have extra properties or extra stuff which we really don't want our customers to know. That is why we always create our own view model, okay, meant to expose to the front end, or I would say from the controller. That is what it will return. So in order to achieve this, we need to create the models. Okay, so the models are now should be accessible from servers, or it should be accessible from the controller, which means the model needs to be in a place where it is which can be consumed by any project. The good place for us to put the models is core, expense tracker.core project. That's where you put this model. Okay, so that it suits the need, and then even the data layer or service layer or the web project layer can access this. So let's create a folder called models, and here I'm going to create a class called user profile model. Right click, add user profile model. Again, this is going to be a public class, and I'm going to copy paste a couple of properties that is exactly there in the user profile entities. Okay, instead of giving everything, I just wanted to give these things. I wanted to expose only these things. Okay, so now it's exposed. I don't need to do all of, see, I don't want to expose all of these things. Okay, so I expose only whichever is required in this model. Now let's go to service and return task of user profile model instead of user profile itself. Okay, so we converted the entities into the user models. Now let's create an implementation class for this user service, which means public class user service, and then you inherit the interface, which is iUser service control period. It will give you options, bring up everything that was needed to implement. CTOR, put a tab, it will create the constructor like this. Inject the iUser repository here, because from the service you're accessing the repository, so iUser repository. So now this is another example of creating based on .NET Core 8. It's called primary constructor. You don't need to have a explicit constructor. Instead, the constructor is on the primary class level itself. Okay, this isn't just an example. I just want to give you different flavors, guys. All right, so here we are returning user repository dot get user ID. Now you see this, we are receiving a task of user profile, but we're trying to return user profile model. So we need some conversion here. So let's create a private method that maps this user profile to the user profile model. We send the user profile, and then we create a corresponding user profile model. Okay, that's what it is. So now what we do, instead of returning this, we will assign the incoming data to the user variable. We'll use the await, which means we need to use the async keyword over there. Now we got the data. We pass this data to the map to user profile model method. So if it is not null, call this method, pass the user. If it is null, just return the null. So this is satisfied, which means now we have a single method in repository, in servers. The next one is our controller. Let's clean up the existing controller, the weather forecast one. Let's remove the model. Let's remove the controller. So right click on controller, add controller. If you click that, it will give you this option, choose on API, choose the API controller empty, again empty. Here you name it as user profile, or let's say users. So users controller, the moment it create, see, it's inheriting from the controller base, and then it has some decoration in line number 6 and 7. It says this class is an API controller, and then it route starts with API slash followed by the controller name. When I say controller name, it's API slash users, not users controller. Okay, it knows how to remove the controller. um, and then it uses only the name. Again, a primary constructor CTOR, here you need to inject the user service. Okay, so .NET Core 8 is all of dependency injection. So we can in the runtime we can ask for an instance of a particular class. That's what the dependency injection is all about. So here we just need to access the user service, so we injected it and then we have it in the local variable. Now we need to create a controller method. So public, let's create a new controller method. Public action result, that's what you generally do for a synchronous one. And then it is going to return of type user profile model, so you can explicitly specify what it is returning, user profile models, and then it's just a get call. Okay, now here is what it needs to be changed according to our asynchronous concept. So the name of the method is changed to get user by ID. It's accepting ID as the input. It's a integer type. And then you decorate this with the http method. In this case, the method name is http get. So http get, you open the bracket and then you specify what is the parameter. The route parameter is ID. That's why we specify that in this way. Okay, so this ID and this ID in the line number 20 should match. The name of the variable should always match. Now if we convert this into asynchronous, it is going to be a task of action result of user profile model, and then we can rename the name of the method also. Okay, now let's start writing the code to call the services. So user service dot get user ID async. We will now store this value into the user variable when we use async await. This is how you use. Now we got the data. The data could be having a real data or it could be a null depending on what ID you pass. Okay, now we already learned about this HTTP status code, right? So if you're looking for a resource and if the resource is not there, then we will check this condition and return not found. This will eventually return 404 status code. Okay, if everything is good, if user has some data, we return 200, which will eventually return a 200 status code. So this method itself is returning either 200 status code or a 404 status code. Okay, the last part is to configure these dependency injections. So go to this program.cs. We have to configure these services that we built. So we built I use the repository, I use the service. For that you need to have this builder.service.add scope. See, this is the scope thing. There are three things: add scoped, add transient, add singleton. Singletons means the instance is created only once throughout the application, and transient means every single time that you request for a dependency injection, it will create a new instance. Add scope means for an incoming given HTTP request, throughout that lifecycle of the HTTP request, only one instance can be present. Okay, but the best is to use the add scoped per HTTP request. Scoped, it's scoped to HTTP request. Okay, so you configure these two things, then everything looks good. Let's run and see whether it works. So the application is loading. We got this endpoint automatically. Click on try it out. You see this, the Swagger is coming automatically. Let's understand where the Swagger is coming. Okay, so let's go to this program.cs. Do we have it? Okay, so let's go to this one first. Okay, so the package called swashbuckle.asp.net core, that's the package that's installed automatically when the template came. And not only that, if you come to this program.cs, you see this builder.service.add swagger followed by the middleware app.use swagger and use swagger UI. They're all automatically there in the code. That's why it is reading the the structure of our code and building up this automatically. So let's put some random number. Okay, we got error, which is valid error. You remember we were talking about the connection string, we forgot it. So basically there is no connection string. So I'm going to copy paste the connection string and put it into the app settings. So go to the app settings, and then here there is something called a DB context connection string should be present. So I'm going to copy paste it. So connection string is the section, under that DB context is the name of the property, and still it's going to give you the answers. Okay, so it read it, now it was able to talk to the database. And finally we got 404 because that was not present. Let's put some number which is already present. See, we got the data. All right, so the complete flow from the start till the end for a given endpoint is success. That's what we can claim now. It's pretty much easy. The application is simple one, that's why it is easy. Generally speaking, you will have to add more business logic in the servers and do some more work on the database side, but that's what it is. Okay, so this is a simple one. So we know now how to build database layer, service layer, and all of those things. Next, what we're going to do is, based on what I showed you, these are the methods that I need to be put into the iUser repository. Basically, for a given family, it's going to get you more than one user profile, and in order for us to add a profile, add user async, update user async, to update it, to delete a user ID, so all the code operation related stuff, right? That's what it is. So once you define this, you have to implement it in the user repository. I'm going to copy paste whatever I implemented, and let's go over one by one. Okay, all right, let's rename this to underscore context. This is not the place. All right, I'm almost done. It's not place, it's underscore. All right, so let's go through one by one, right? The second method is what we have to start. It's basically a family item based user profile. So user profile dot var is a link queue extension operator for the class. You can pass the var and you can match that family ID and then convert into .toList async. They're going to use asynchronous, so for most of the methods everything is asynchronous available. For add, you say user profile dot add, pass the user profile, and then context dot save changes will save the record into the database. Similarly, for update dot update, you pass it. So for update alone, you remember one thing: when you pass the object user profile, it has user profile ID. User profile ID has to be filled up, and it has to be a real user profile ID in the database. So that's how entity framework will figure out, okay, this is the record that I need to update. So it formats all the queries and then updates is based on the user profile ID that you pass. But for add, user profile ID can be 0 because it's going to generate it. Okay, now similarly for delete, it is same again. We try to find out whether the record is present, and then if the record is present, we say dot remove. Dot remove will make this entity framework to start tracing the records. Like basically it will mark this entity as to be deleted, and when you do dot save changes, it creates the query that will eventually delete the record, and then it executes the query. Every time that you do dot save changes async, it will return more than 0 record impacted, which means some record is affected. All right, so based on that we created this. Okay, so this is all simple, that's why I'm not going too deep. Basically it's very simple compared to what we have done in the e-commerce application, or even the other applications that we have done, right? The table booking app, that's the heavy application that we did a lot of stuff. Okay, compared to that, this is just nothing. This is like a baby application. Okay, now just to speed up and keep it simple of this microservices and web API full complete concept, so we created this repository. We need the equivalent other thing also on the services, but let's create iExpense repository also. So iExpense repository also have similar stuff how we did for the user profile. Here the last three methods kind of an utility, I just grouped it into one repository. When I say utility, basically it's a static data that always will be there, we just need to retrieve it. So it's going to be just a get method. Okay, and that's why I call that as a utility. You can even create utility repository and move these three into that repository. Actually, I would suggest you do it when you do it. And then again, for I expense repository interface, we need to implement that. So we will create an expense repository interface, not interface, the class, and then we will replace this. Basically, whatever you saw in that is what in the user profile repository is what in this repository also. Okay, we are just dealing with the different classes here. So here if you see, we inject the constructor. For each method, it is just going and taking the records for expense.var user id is equal to this, get all the expense id. Okay, so basically it is all same for this one. It's two things, right? Dot var, we find out the n number of users, and then we go to the expense.var where we convert any of these user ids to get all the family's expense id. Okay, so these are all, like, if you guys are familiar with some little programming in C#, this is just nothing. All I wanted to teach you in this web API is how you generally do it, setting up, accessing database, and some important core concepts, how it works. Okay, so this is what the expense repository class will look like. So in order for us to have the respective models, so I created two more class called family models and the expense model. So this is, again, instead of using the entity directly, we will be using our custom model. So family member model is basically, it will have one family ID and family name, but list of family members, they're nothing but the list of user profile models. Okay, let's say husband wife is in one family. So when you call when you send this model, family name will come and two profiles will come. That's the whole concept. Similarly, I have another class called expense model. I'm going to copy paste a bunch of custom made classes. Basically, expense model, expense type model, expense category model, and credit card model. The last three models are based for their utility thing, like, just to retrieve the data. Eventually when we use the UI, we need those things to build our UI nicely. That's why we have those things in place. Okay, so we have all of these things ready. Now let's go to the services. So all what you have to do is, we have to create I expense service, which is going to call the I expense repository. So most of the interface methods will be same. The only difference is here we will be using this custom made models instead of returning the direct entity itself. I explained you in user profile, right, how we did exactly same. Okay, so we will be exposing our custom built models again. Now this is our time to implement the expense service. It's kind of a relay. See, in a real world, trust me, in a real world, this is not going to be like this. Okay, here lot of business logic layers, business logic will come. It's not going to be like this simple. Lot of stuff people will do based on the business requirement. Then only, like, in this one method itself, they might call multiple database methods to get some data, those kind of things. So it's not going to be very simple like this, but at least you should know how controller is calling service, how service is calling repository, and how all these things are hooked up. Okay, similar to how we have this map to expense model and the entity model, that similar mapping is present, and rest and all is same, my friends. They are nothing more difference. Really, I wanted to save your precious time. Just by reading whatever is in the screen, it's not really going to help you, or duplicating the code and explaining you, typing and explaining you is not going to helpful for both of us. Okay, so these videos are not done for namesake. This is something that really wants to deliver value to you guys. Now let's go to the user controller and add all the remaining methods, like the code methods, right? All what you need to know here is, the first one we built, it was http get. You see this, the first one is the http get, and then we have another get method, but here the route is different. You see the line number 30, family/family id. So here the routes are different. Okay, we get this error. Why do we get this error? Because user service doesn't have the remaining methods that I'm supposed to do it. So I'm going to copy paste this method that will bring up all the I user services methods. Okay, so let's go. Okay, so I got all of these things, everything looks good. If I go to controller, all of these errors are gone. Okay, I didn't do anything magic. It's basically whatever I explained you initially to fill up one full flow. That's what it is. See, line number 30 again, it's a new method, new URL, which means family API slash user slash family ID. Because this is under the user controller, so it is going to be API slash users, that's the default prefix, slash family ID. Similarly, for add, you can just don't need to put any a name, so it's going to be API slash users, that's going to be the post method. Okay, so only one, generally one post only will be there for each controller. Okay, similarly for update, you have to pass the ID as well as the model. What, see here, this is what no content is what 204 is. Basically process, it doesn't have anything to display. You can even send okay message and return back whatever you updated. For delete, no content, right? There's nothing to be sent back. This is just a typical example that you use for delete and all. So basically no content means we accepted, we received your request, everything looks good, we are going to process, and there is no content to display. That's what this method says. Like I mentioned here, you can also respond OK method, which will return a 200 OK status, and you can return exactly the model that you updated. Like after you update whatever data is there, you can call that and return that as well. There is no hard and fast rule for you to return a no content on a update statement. Okay, that's absolutely fine to return a 200 OK. Now it's time for us to put the expense controller. Again, let's go over it. It's going to be the same API slash expenses, and then a bunch of methods that I declared. First thing is the HTTP get. We have different HTTP gets. Post, put, types. So it's returning all okay for all of these types, categories, and credit cards. It's returning all okay, and then let's run it and see whether we get the data. See, we have a running application. It has all of these things. Let's execute one by one. User, I'm going to put some name and see whether it runs properly. Okay, see, 201. I created a record and it's number 9. So let's go to get method and place this number 9 and see whether it comes. 9 is the one that we created. We got the response. So our get method is working. Our post method is working. If we try for a put method and change it, so let's copy whatever I got it in 9, and I'm going to change this to 9 because we need to send it. And let's say I'm going to change this, okay, just to make sure that our update is working. So everything looks good. See, we got no content. Now let's go to the get method and let's see, we got the updated code. Execute. See, the data was updated. Okay, so similarly, if you pick up some of the records and then try to delete it, it should work. See, 404 is also coming because there is no such record. 5, there is no such record. How about 6? All right, 6 is there. So let's go to get, let's go to delete, try it out, execute, got deleted. Great. See, now we are getting 404, which means it got deleted. Alright, so our testing looks good. Similarly, if you do all of these operations, it should definitely work. So quickly, let's test that as well. So with the flow that I have done, let's gonna click this. Oops. Alright, so it says unable to resolve services for blah blah blah. Okay, I expense service. Great. So these kind of things can easily happen. So basically, whatever I created, I expense services, I expense repository, we forgot to totally, I forgot to totally put it into the configuration. You remember, we have to do this dependency injection configuration here. If you don't do it in the runtime, it is trying to inject a service and it just don't know what to give. whenever the constructor is asking for iExpense repository or iExpense service, it just doesn't know what instance to give. So if you put this configuration here, whenever the constructor or wherever you're asking for a dependency injection for an instance of a class, this will definitely work. So we have to reboot the application. This may not work. Let's try this. Do a hot fix, like hot load. It says hot reload is not working for this. Okay, it's just that already this code is ran and this code is never executed again, because this code is ran only one time, right, the main method. So it just doesn't know whatever we applied is working. But if you restart this application, definitely it should work, which we're going to try now. Execute. See, we got the data. Looks good. So that's how you test it. And at this point of time, if you want to pick up all the code from the GitHub, please feel free to do it, and you will get the data. See, I quickly added one item in the expense for a given ID for the given user, so that got created. If I go to expense ID or maybe user, based on the user ID, right? So if I pass 9 here, ideally that one record that I created under one particular user should come, which is coming. All right, so this is more than enough for me to finish it. The next set of important things are very important. We are going to talk about Serilog, application insights, exception handling, global exception handling, all of those things in the next 15 minutes. So stay tuned, continue on this video. All right, so now we did all of these things, but what happens if we encounter error? We never did anything related to the error handling, right? So we are going to use a powerful logging framework by Serilog, and that is what we are going to use. And for now, let's focus on Serilog logging to see how good you can log the details, right? So we're going to use that framework, and that's what is next. So let's go to the expense tracker.web project, and here I need to install a couple of packages for the Serilogging. So serilog.expression, serilog.asp.net core. Okay, serilog.asp.net core is twice, so let's remove this. And then the last one is serilog.syncs.application insights. Anyway, the third one is really not required for this one. The third one is for the next topic of the application insights, but basically the two things is important. Okay, the expression and the ASP.NET Core Serilog. So now we built those two packages are installed. What we are going to do is we are going to start with the logging mechanism. So at the top of the main method, let's initialize the logging. Okay, so this is what you called it's coming from Serilog namespace. So log.logger equal to, we are going to we are to configure the logging. So logger configuration, we are saying write to .console debug information from context, and the last method, right, .create bootstrap logger. So it's going to initialize the logging mechanism. And what we are going to do is let's create a try catch block, because we want everything to be captured. Okay, even if there's a fatal error, we need to capture. So I'm going to use the fatal log.fatal to say host terminated successfully, and then we will flush out in the final stage. So let's cut every single code and put it into the try. Okay, all our configure services and app building stuff, the middleware is now in the try catch. It's in the try. Okay, so that is done. Now let's bring in a piece of code which will do more configuration on our logging mechanism. Now you don't need to mug up or by heart any of these things. They're all available in the Serilog.net code documentation. I have used this enough time. So this configuration itself I have been using from other application. So this configuration itself is something that I'm using from other application. So what we do here is we are saying builder.host, we are using the use Serilog as the pipeline kind of stuff, and then we are doing some configuration. So we are saying read the Serilog configuration from the configuration, read it from the servers, and then when you write it in the console, use this kind of a format. Okay, this format will tell Serilog how to write the logging mechanism, and then the last piece, right, line number 39 to 41. Basically 39 to 41 is really not for this logging, it's for the next topic for our Azure application insights, how you can use Serilog to push the telemetrics to the Azure application insights. So I'm gonna clean up this, and let's clean up this so that it's not confusing for you guys. So we added like application started, something like that, right? So starting the application, there is something wrong in that text. It's copy paste mistake, so it says cart and wish list service. Basically this is expense tracker service. Anyway, by the time you get, I'll be correcting this. Now go to this application.json. This Serilog configuration is going to be same, so I'm putting it here. However, there are some times where you have to write it in a different logging places, then each environment will have different stuff. Anyway, so what do we have it here? We have something called Serilog section. Under that, minimum level logging, what you need to overwrite, and there's something called write to, right? So write to, have a section called file. I'm saying write all of these logs into a new file, and the path location is where the application is present, wherever the bin folder is there. Under that logs, create a file. Okay, it's every day you roll the file into a new file. That's what it says. An application is just a name that is going to use. I'm going to use that name as expense tracker web API. So this is the bare minimum stuff that we need. So it's giving us error. Let's see. Okay, there is some small pending work here. Okay, I missed probably a parenthesis here, so I added the parenthesis. Now if you run, it should work. Okay, so look at this, it started and it is giving us some information like what it is loading, all of these things, right? So some logging is coming now. Instead of nothing, something is coming. Even if you try to execute this, it should give us some logging. You see this one. All right, now let's make this more interesting, right? So it's giving only bare minimum logging. So I'm going to introduce something called request and response logging. So here you can see, it's even executing the database stuff. All of this database query you can see without the parameters data. So logging is working perfectly, but let's make this a little more interesting. So I'm going to apply the exception handling on the middleware. That will be like, because it's a middleware, what will happen, it will go through this and comes out of this. So anything that goes wrong in the code, this layer will get caught and it will going to put the error details here. So log.error, you pass the error information, it's going to absolutely put everything on the console for us. Not only console, wherever we are asking it to write, it's going to write it. Okay, so this is a small simple method that you can have the exception handling done globally. Now you see this under the middleware folder, there are 3 classes I copy pasted, but let's go one by one. Let's talk about let's talk about this one, which is called request response logging. Basically what I'm doing is, when the request comes, I log that information, including its body, its whole URL, and then when the processing is done, right, I am going to capture the response of the content, log it and send it back. That's the only thing I'm doing. So which means the request and the response that was sent to the client is being captured and recorded in our logging. This will be much useful in the real world, depending on how big the application is. This might be like too much logging, so or maybe you can enable this on a conditional basis. Whenever there is something going wrong, you need to troubleshoot what is incoming, what is outgoing, you can randomly enable this with the configuration based stuff. So that will, like, you read based on the configuration and you update the configuration in the database, so dynamically you can update without you touching this application code at all, right? So now we have this one middleware, so we use that middleware here, app.middleware request response logging middleware. Bring the namespace of that, so middleware is configured. Now if you run you see the difference in the console. Okay, you will definitely see some information in the control. You see this now, this whole HTML is getting logged. This is nothing but our response of our Swagger API. This is the one that you saw. So basically now you see it's going to execute something. I'm going to do some number. Request is received, response is also logged. You can see 404, it's getting logged. That's the response that we sent. See this 404, and request is also received. Probably if you put some valid number, it will give you the data that was returned as well. Let's execute this. You see this response is also recorded. Okay, see, I'm gonna enlarge it. This is what the data that was sent with the 200 OK, and everything is recorded. See, Serilog is going to help us along with some extra middleware layers that we have configured. The logging is perfect now in our application. Logging is like very important. Without logging, it's very difficult to troubleshoot what's going on with the application. You cannot fix anything. So logging is very important. Okay, even if you try to blow up the system, see, exceptions also recorded. I'm intensely showing all of these things for understanding purpose, guys. Generally, exception and all should be handled properly. Maybe we should add more validation. I'll cover it in a separate video to include more validations. How you can do proper validations using fluid validation or validatable object interfaces that's inbuilt. Now the next thing is, let's add up these telemetrics information. What happens if you push all of these superb information into Azure Application Insights? That will be more interesting, right? Because you can store a lot of information in Azure Application Insights. You can query there, you can visualize exactly how things are working, how many requests are coming, how many requests are going, failure rates, this, that, so many things that you can do with Azure Application Insights. It's actually free for us. It could cost something for the organization. That's okay, because organizations are anyway, this and all is nothing. $3, $5 is just penny for them. All right, but for us it's free, so don't worry. Feel free to do whatever I'm doing. So let's do some more installations of the NuGet packages. This is the one that I'm highlighting is required from the serilog.sync.application insights. The next two more thing that we need is microsoft.applicationinsights.asp.NET Core, followed by the logging.azure app servers. So 3 packages for this if you're using Serilog plus Azure Application Insights. Okay, if you are using only Azure Application Insights, just 1 package is enough. Now here, little more modification on the application settings. So I'm going to copy paste a new one and explain you a bit. See, I have a section called Application Insights section that tells us the level of log, and then there's a connection string under the Application Insights. This is the connection string that we will be replacing it from the new one that we will be doing it now. So under Serilog, there's a using section. We are saying use this one, use this sync.application insights, and there's one more write we have added here. We're saying write all of this information to 2 places. One is file system and another one is application insights. So this is what the configuration that we need to use. All what you have to do is, in this whole code that you get, you need to replace the connection string alone. Okay, now I added 2 more middlewares. One is request body middleware and response body middleware. What is the difference between this and the previous request and response logging middleware? Basically, in this one, kind of same, but these 2 are specifically meant for Azure Application Insights. Basically, okay, so right now whatever you're saying is the middleware that's the service that you need to hook up, build.service and application insights. Okay, so basically what I was referring to is those 2 middleware is to specifically add the telemetric with a new property and push it to the Azure. Now go to portal.azure.com. Under that, search for application insights. You will land here. I have a lot of things, right? Click on create, choose your subscription, choose a resource group. This is just a demo, so I'm going to create one resource group. That's for my understanding. Generally speaking, you give some meaningful resource group. Resource group are nothing but a collection of resources are under that. Tomorrow if you decide to delete, you can delete the resource group. Everything is cleaned up. So after this demo, most likely this temp rg is something that I will delete it. Okay, so I'm giving a name, region, click on the tag section, put some tag for the understanding purpose, right? So I'm giving this tag, it's a key value pair. Tag is used only for billing purpose to find out how much you're using it, nothing else. And then for the simple demo, create this resources created, go to resource, and very simple. Once the deployment is success, click on go to resource. Click on go to resource. You see this, this is the overview plate. There's something called instrumentation key and connection string. Copy the connection string, and right now there is nothing on this section, like nothing is loaded. We are going to use this connection string. Come here and paste it in two places. Under the right to connection string, here line number 32, you copy there, paste it here. Scroll up, there is another section called application insights. This is the main application insights section used by the application insights package. Now this is going to be interesting, right? So these telemetrics will be added to the Azure application insights login. So just to recollect, we added the application insights packages, and then we attached the application app settings.json file, and then some middlewares to hook up these things. Okay, nothing else. We did great in this. Only these three simple steps will make us succeed of proceeding with all of these changes. So this is also interesting, right? Now, one last thing that I was referring to is those two extra middlewares that I was referring, right? The extra telemetrics. So that also is possible. I'm going to show you that now. So first one is the request body telemetrics. So request body means I wanted to record the incoming request to the Azure App Insights. See here, there is something called, this is just a middleware, okay? It's going to read the incoming request. And if you see line number, this one, the one that I'm highlighting, context.feature.get request telemetrics, that's coming based on our application insights package. We are saying, hey, do we have this property called request body? If not, add that property and add this value. Similarly, for the response, add a property called response body and add a value. I'll show you in a moment how this beautiful things are recorded in the Azure application insights. So these two are the middlewares, which means we need to come up to the program.cs and hook it up here in the middleware section. Because this is to our middleware and the services, so we will inject the transition services of these two classes and come scroll down to the middleware section and hook it up after line number 93. Okay, so once you do the service configuration and the middleware configuration here, we are good to go. We're going to hit multiple times the request and see how the records, how the data are recorded. Remember, in order for this to work, you just need an internet connections. Magically, as long as the connection string is valid, these data are magically pushed from your local machine to the Azure application insights. And that is what we're going to see in this demo. It will be magically pushing everything from a local development content to the Azure application insights. So hang tight. I'm going to execute multiple different APIs so many times just to generate more loggings, right? Whatever we have done, right? That's all going to be generated by doing this. I'm just mimicking up, like simulating a real-time user experience. When our APIs are hit by so many requests, what happens? Exception 404, valid data, it could be anything. Let's get recorded and then we will visualize those things. All right, so let's generate more stuffs. All right, so now we have enough stuff generated. Go to this place and I'm going to click on last 30 minutes. So I see some numbers coming up, right? Some server record, server response time, failed requests, and all of those things. So let's go one by one. Let's go to 30 minutes, click on server request. So whatever I generated in the local, now magically it has come to this place, like on the Azure portal. So you can also see a lot of different endpoints has been listed, and one of the endpoints shows 6 items, and you can click on 6 samples. You can click on any one of the samples. Say response body has nothing data, some custom property has all of this stuff we did. Let's click on something else. There's one item and you can see all of these things. So if you click a particular exception, see request body. This is the request that was sent and this is the response that we received. And basically we sent intensely some incorrect request, that's why response was having a 400 error. So this is how you see errors, valid errors. Now let's go to the failed request, and failed request is having under this add user, we have some 500 error, 400 error. 500 error is basically something related to the database, right? So let's expand. You can also see these details here. The good part is, right, you can also see the request also, and you can see, click on view, see the request is coming. You can pinpoint every single thing, like starting from the request received until it was sent back with the response. You get to know every single thing. So Azure Application Insights are very useful and handy tool for logging mechanism and to troubleshoot all of the stuff that you have, and easily you can figure out the issues. All right, so by this time we have come to an end of this web API series. I have done I've showed you all of the basics and important things that you really need to know about a web API and microservices. I hope you really enjoy this video, guys. Do it by your hand, practice to succeed. If you have any questions, do let me know in the comment section. If you like this video, give me a thumbs up, write your good comments on the comment section, and share this with your friends. Don't forget to subscribe. I will see you in the next important interesting videos. Thank you. Bye bye. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more tech tutorials. And don't forget to hit the bell icon to get notified when we post new videos. If you have any questions or suggestions, leave them in the comments below. Happy coding!